Good day everyone. Today we are doing inequalities. What you have to know is that if you are doing inequalities, we have got these signs that we are going to be dealing with. We've got our less than or equal to, less than, greater than or equal to. These signs are treated the same way as an equal sign. They are treated the same way as an equal sign. So there is our first inequality, which says 2x plus 5 is less than or equal to 7. So we solve it the same way as we solve our straight line equation. So it's 2x is less than or equal to 7 minus 5. 2x is less than or equal to 2. Then I'll divide both sides by 2. I'll divide there. My answer is x is less than or equal to 1. It's a 1 there. If x is less than or equal to 1, you might find a question requiring you to illustrate your solution on a number line. So what you do, you're going to come here and draw your number line. You sketch your number line like that. So we sketch our number line like this one. If x is less than or equal to 1, this is our 0, 1. This is our 2, negative 1, negative 2. The concept is on a number line, any number to the left is less than any number to the right. Now I'm supposed to illustrate this on this number line. X is less than or equal to 1. Which values are less than or equal to 1? They go that side. So I'm going to come here and draw a shaded 0. What's the reason? Why am I drawing this shaded 0? It means that this value is included. Amongst my answers, that value is included. So I'll indicate the direction where my values lie. So I've illustrated my solution on a number line. Let me go to the second one that might be solved maybe that up here using what? Using brackets. You might find a question like this number 2. This is our number 2. Then I'll say 2x plus 3 bracket x minus 5 close is less than 20, is less than 20 like that. I'll come here and say 2x plus 3x minus 15 is less than 20. I'll then do what? I'll then collect my like terms. Now 5x is less than 20 plus 15. If I'll come and continue this side, it's going to be 5x is less than 35. I'll then divide both sides by 5 by 5. It's going to be 7. X is less than 7. There. That's my answer. If the question says illustrate your solution on a number line, now what you are supposed to do is to draw your number line that end up with what? With 7 like that one. So let me draw this number line here and say it's like this. So there is the number line. The answer says x is less than 7. It says it's less than, so it means that I'm supposed to draw a plain 0 there. This means that this value is not included. So if I'm to say let's list the values of x, they start on what? On 6, not 7. So that's why I'm drawing that unshaded 0. So these are just simple linear inequalities. So now let's move on to what? To simultaneous inequalities. Simultaneous inequalities. Let me give you an example of a simultaneous inequality. Okay guys, there is an example of a simultaneous inequality. I took this question from November 2009. I'm going to use it as an example of a simultaneous inequality. Now what you have to know is that we split a simultaneous inequality using the terms that are found in between our signs. In this case, I've got just 10x. This 10x is supposed to appear twice. It's supposed to appear twice. So firstly, it's going to appear like 5x minus 5 is less than or equal to 10x. It has appeared there. Secondly, it's going to appear, firstly, it's going to be 10x is less than 8x plus 10. If you know how to split a simultaneous inequality, then you are home and try. If you know how to split, then you're home and dry. After this, then you solve them one by one. So we're going to start with that one, with the 5x minus 5 is less than or equal to 10x. I'll then correct my like terms there. Minus 5 is less than or equal to 10x minus 5x less than or equal to 5x. I'll divide both sides by a 5 by a 5. Yes, now negative 1. So negative 1 is less than or equal to x. You don't rearrange your answer just because this is not your final answer. I'll come here and solve that one. It's a 10x. I'll collect my like terms. Minus 8x is less than 10. Then 2x is less than 10. I'll then divide both sides by 2. By 2 there. It's going to be 5. So x is less than 5. This is my second answer. Then I'm going to the final answer. Now we are supposed to understand this. Most exam question papers, they give you the format that in which you are supposed to leave your answer in. They tend to say leave your answer in the form of a is less than x and x is less than or equal to b, where a and b are what? Are integers. It's not necessary for you to keep in mind that we have to follow what the question paper say. We are supposed to use this concept. On a number line, any number to the left is less than any number to the right. Fine. You come here to your answers. Which one is the bigger number? Which one is the smaller number? We determine here in this case our 1 is what? Our negative 1 is the smaller number. Then we've got here our 5, which is the biggest number. You come here and say we're now inserting our final answer. So we've got negative 1. We'll leave a gap for the what? For the sign. I'll put my what? My x there. Then my larger number is what? Is 5. Then put your signs the way they were. So that's why I'm saying you are not supposed to rearrange that one. So in this case, the sign was saying negative 1 is less than or equal to. So I can say is less than or equal to x. Then x and 5, it was x is less than 5. That's your answer. That's your answer. Now, if the question requires you to illustrate your solution on a number line, in this case, our November 2009 paper 1 had given us a what? A number line where we're supposed to put our what? Our illustration. So the number line starts from what? From negative 6 up to positive 6 there. So there is our number line. Where we want to illustrate now, we have to consider this negative 1. What was the sign saying? It was saying less than or equal to. So at negative 1, I'm going to put a shaded 0 there. Then what about between x and 5? It was saying less than 5. It means this 5 is not included. That 5 is not included. You then join this with your what? With your ruler. You then join this with your ruler. That is your final answer. You have illustrated there. You have illustrated. Then sometimes you find a question requiring you to write down the values of x. In this case, our values of x, they start from negative 1 up to what? Up to 4. Then amongst those values, the question might say find or write down the largest value or the least value of x, or write down the list of perfect squares, or write down the list of odd numbers, whatsoever question you may come across. So those are typical questions that you may find in inequalities. So let's go to the other example that I have here from other question paper. Okay, so we're going to obtain our other exam from November 2015. That's paper 1. That's paper 1. The question is number 12. There is the question. The question says solve the inequality. There is the inequality. Giving your answer in the form a is less than or equal to x, and where x is less than or equal to b, where a and b are what? Are integers. As I said, it's not even necessary for you to master this, guys. It's not even necessary for you to master this. I'm going to give you some examples where you will find some questions. They don't specify that leave your answer in that form, but it's a must for you to know that how to arrange your final answer. So let's try to solve that question. here, as we solve our question, we're going to say, as I said, where do we split our inequality? In between there. You're supposed to know it on how to split an inequality. In this case, I'm going to say 2a minus x is less than or equal to 2x minus 1. Then the second is what? 2x minus 1 is less than 11. Then you solve these inequalities one by one. You are going to solve these inequalities one by one. So let's solve these inequalities one by one. I'm going to start with that one. I'll collect my like terms. So I'm going to have 2 plus 1 is less than or equal to 2x plus x. I'm collecting my like terms there. So now 3 is less than or equal to 3x. I'll then divide both sides by 3. So it's now 1. So 1 is less than or equal to x. That is my answer. Then I'll solve that one. I'll collect my like terms. I'm going to have 2x is less than 11 plus 1. So it's now 2x is less than 12. Divide both sides by 2. It's now going to be 6. So x is less than 6. That is my answer. The question didn't require you to illustrate your solution on a number line. Now I want us to put our final answer. As I said, we have to consider which one is the largest, which one is the least. The least is what? Is 1. We use the concept of saying on a number line, any number to the left is less than any number to the right. In this case, which one is the least? The least is supposed to be on your left. So I've got a 1 here because it's the least. Then I'll leave a gap forward for my sign. I'll put an x there. I've got a what? A 6 there. I'm now going to my final answers. So in this case, between 1 and an x, there is the sign. It's like that. Then between x and a 6, there is the sign. You realize that you have answered the question. Even if you didn't consider that one, your answer will always tally there. The concept is on a number line, any number to the left is less than any number to the right. So that is our final answer. We are done there. It's not necessary for us to illustrate the solution on a number line. So that is the answer. Let's move on to the other example that I have here. Here comes our other example. It's number 4b. It's from 2014. It's a replacement paper. Solve the inequality. You are not given the format in which your answer is supposed to be arranged. So you understand how we factor in that concept. Then in this case, we are required to illustrate our solution on a number line. So let's try to solve this inequality. As I said, we split it here. So we rewrite this inequality after we have splitted it is less than 4 minus 2x. The second one is 4 minus 2x is less than or equal to x plus 13. We are now solving these inequalities one by one. We have to solve them one by one. So I'm going to start with this inequality. I'll just go and do it and collect my like terms here aside. So I'm going to say it's x plus 2x, which is less than 4 plus 3. I'll say 3x is less than 7. I'll divide both sides by 3 there. So this one, it's a mixed number, it's 2 and a 30. So x is less than 2 and a 30. It's correct there. Then now I'm going to that one. I'm going to have 4 minus 13 is less than or equal to x plus 2x. Then 4 minus 13 is what? It's a negative 9 is less than or equal to 3x. Divide both sides by 3. It's now a negative what? So negative 3 is less than or equal to x. That is my answer there. So now we want to illustrate our final answer. In this case, which one is the least? The least is what? Is a negative 3, because 2 and 30 is what? Is bigger than this negative 3. So I'm going to come here and say negative 3, I'll leave a gap here and put my x there. I'll leave a gap and put my what? 2 and a third there. I'll then follow my signs. They are like this, and that there is my final answer. That is my final answer. I'm done there. Then I want to illustrate my solution on what? On a number line. Since the question demanded me to illustrate my solution on a number line, there's the question. Illustrate your solution in part B1 on a number line. So let us try to sketch the number line. So now we want to give out our final answer there. As we illustrate our -3, we're going to put a what? A shaded dot there. Then where is our 2 and a third? We're not going to put there. That is what? That is a 2. So 2 and a third is here. We just used an estimation. It's around there. Then what do we do? We now join our what? Our dots like that. You might find maybe a question requiring you to do what? To give a list of what? Of these answers there. So maybe if a question might require us to give a list of the values of x, here we are going to use a whole number, what? 2. So it's your values range from what? From -3 up to +2, which is our whole number there. So that's what you are supposed to understand. Let me give you the other example of a simultaneous inequality there. So our other example is going to come from paper 2, June 2019. Paper 2, June 2019, that's number 7A. There is the question. Solve the following inequalities. Given the answer in the form, as I said, you're not supposed to even worry about what? About that form. Where A and B are constants to be found. There is the inequality. We just have to do what? To split our inequality. Let's try to solve that inequality. Let's try to solve this inequality. Where do you split it? We split it there. It's going to be 5x minus 13 is less than or equal to x minus 6. Then x minus 6 is less than 9 plus 4x there. We solve these inequalities individually. We're going to solve these inequalities individually. So we're going to have 5x, automatically to what? Correct my like terms. Minus x is less than 13 minus 6 days. Now 4x is less than or equal to 13 minus 6x. That's what? That's a 7 there. Over 4. So from this one, I'm going to have my x is less than or equal to 1 and what? 3/4. That is my first inequality. Then I'm going to what? To that other inequalities. I'm collecting my left hands. I'm going to have -6, -9 is less than 4x, negative x there. It's now -15 is less than 4 minus x. That's a what? 4x minus x. That's a 3x there. I'll divide both sides by a 3. Then that's a what? That's a 5 there. It's now -5 is less than an x there. Now we're moving on to what? To our final answer. The concept remains the same. Which one is the least value? Which one is the greatest value? The least value is -5, then x there, then 1 and 3/4. I'm going to put that one, then I'm going to put this one. Then this is my final answer then. So in this case, we're supposed to illustrate our solution on a number line. There is the question. Illustrate the solution on a number line. I've drawn the number line there. So considering my answers, I'm going to put an unshaded 0 there, then a shaded 0 where I estimate there might be a 3/4, 1 and 3/4, so it might be here. I'm going to shade and then do what? And then join those 2 dots. I'm going to join those 2 dots here. Then this question requires us to list all the possible values of x. So x is equal to, I'm going to start with what? -4, -3, -2, -1, 0, 1. I won't take that 1 in the 3/4. The question says, write down the smallest integer value of x that satisfies the inequality. In this case, the smallest integer value of x is what? X is equal to what? -4. So that is your answer. That is the smallest integer value of x. In this case, if you're answering this question paper, which is a what? Which is a fill-in, we are going to come here and say -4 only, -4. So we'll be done there. Then I want to show you this other concept that might appear especially in Cambridge exams, in Cambridge examination questions. You might find a question might appear in the form of a number line that will require you to deduce that one. Let me give you an example. So guys, if the question appears to be like that one, then you are required to deduce this. You're going to come here and say this cell corresponds with what? With a -2. You leave a gap and put what? Your x there. This cell corresponds with what? With a 3 there. Then our signs are always facing on the what? On the right side. The reason being that a number line increases to the right, not to the left. So your signs, you will never come across signs facing that side. You will never come across signs facing this side because our number line increases to the what? To the right. So signs are always facing to the right. In this case, I'm going to consider the meaning of that unshaded 0. It means the value is not included. So if the value is not included, I'm supposed to use that sign. Then if the value is included, I'm going to use that sign. That is your answer. The question would have appeared in the form of a number line. Then you will be asked to deduce that what? That expression. So that one will be your final answer. Then this other concept that I want to show you, where you will divide using a negative sign. Let's try to divide using a negative sign. You'll see what happens. So there is an example, guys. Let's try to divide using that -3. If I'm solving here, I'm going to say -3x is less than 11 minus 2. -3x is less than or equal to 9. Then I'm going to divide using a -3, a -3 there. Divide like that. Then here it's a -3. Now, just because you divided using a negative sign, it will convert that what? That sign. This sign is going to be like this one. So now x is greater than or equal to -3. That is your what? That is your final answer. This sign only changes if you divide it using a negative sign. If you divide it using a negative sign. But above all, as I know this concept tends to be what? To be confusing a lot of students. Above all, avoid dividing what? Negative values. In this case, how can you avoid dividing using a negative value? Let me rewrite that question again here. I'm going to say -3x plus 2 is less than or equal to 11. Instead of dividing using a negative sign there, I'm going to collect this -3 and send it that other side. So in return, I'm going to obtain what? 2 minus 11 is less than or equal to what? 3x. Then -9 is less than or equal to 3x. Then you divide both sides by what? By a 3. Then -3 is less than or equal to x. That is your what? That is your answer there. You see, I didn't change my sign. It's still the same thing. Even that one is still the same thing. If I'm to rearrange that one, it's or I'm going to begin with that -3. I'm going to say -3. -3 was less than or equal to, so it's less than or equal to what? x there, you see that this is still 1 is the same thing. So now I'm moving on to the last concept of what? Of these inequalities. We want to do substitutional inequalities, where we will be given this expression and the values of our variables there. Let's do those substitutional inequalities. So here comes this concept of substitutional inequalities. We're doing substitutional inequalities there. So what we have to understand is that, first of all, we are supposed to know the possible values of x, the possible values of y. Amongst those possible values of x and the values of y, we've got to the values that we can't consider. For instance, 0, we can't consider 0, that is our absolute value. So in this case, we're going to say the values of x, first determine the values of x and determine the values of y. So x is equal to, considering that one, x, that is a range of values of x. So x starts from -2 to end at what? At 4. So it's x starts -2, 1, 0, 1, 2, 3, 4. Then y starts as -3 and end at 2. So -3, 2, 1, 0, 1, 2. Now I'm answering the question. I want the least. The least means the minimum possible value of what? Of this required question there. So what is the least? In this case, in order for me to determine my least value, what I understand is that the least value is the negative value. So in this case, I'm going to use a -2, then cube it. I'll then consider that negative. Then here, I'm not supposed to put a what? A negative value. The reason being that it will transform this into what? Into a positive. So I'm supposed to consider what? A positive value. In this case, I'm going to use a 2 there. Now it's negative is equal to -8, -2 is equal to -10. What you have to know here is that even if you have to consider whichever value there is no way you will get a value that is less than a -10 there. Even if you have to put a -1 or 0 or whatsoever, there's no way you can obtain a least value that is less than what? That is less than 10. Then let me take you to this other example. Find the greatest possible value of x squared plus y. The greatest possible value of x squared plus y. I want the largest values only. So the largest value of what? Of x is 4. So it's 4 squared plus the largest value of y is what? It's a 2. It's going to be 16 plus 2 is equals to 18. That is your answer. You will be done there. So let me give you some examples from past exam question papers. So our other exam come from June 2010. There is the question: integers x, y, and z are such that x is less than or equal to 6, y is greater than or equal to -2, and -6 is less than or equal to z, where z is less than or equal to 4. Find the least possible value of yz squared, the greatest possible value of x minus y. What we have to know here is that if we are given values such as those for x and y, we use those prescribed values, those values that we are given there. Then for z, we are supposed to list the possible values of what? Of z. So let's try to attempt that question. Here I've copied the question. For you. Also, this is going to be our last question. I've copied the question for you here. So in this case, we have got the values of z range from -6 up to 4. So I have listed them below. Now we want the least value of yz squared. The least value. Since they require the least value, whenever the least value is supposed to be negative. In this case, we want the negative value of y is what? Is 2. So we're going to say number 1, yz squared is equal to, the negative value of y is what? Is 2. Then bracket, the largest or the value of y which is such that if we square it, it's going to give us a what? A larger number is what? Is negative 6 squared. So it's equal to negative 2 times 36 is equal to negative 72. That is your answer. That is the least value of yz squared. Then I'm going to the second question, which requires the greatest positive value of x minus y. You just take what you see. At x I see what? That's my number 2. X is 6. Then I'll put that negative is negative bracket. Y is negative 2. So it's equal to 6 plus 2. It's equal to what? 8. That is your final answer. That is your final answer. So maybe I can give you some questions that you can do for practice. I can give you some questions that you can do for practice. So let me look for such question papers that you use for what? For practice. Let me look for those question papers here. Otherwise, this is the end of our inequalities. That is the end of our inequalities. So as we move on, we're going to meet on our next lesson where we will be doing laws of indices. We will be doing laws of indices. So let me check for past exam question paper that you can use for what? For practice. So I have a lot of question papers that we are going to use for practice. Here it's a November 2016 paper 1. There is the question. There is the question number 25A. We can use that question for the sake of practice. We can use that question for the sake of practice. I think everything is clear there. Let's try to use that question for the sake of practice. It's November 2016. That's our paper 1. That's our paper 1. Let's use that question for the sake of practice. Then the other one is we have got our June 2013. That's our paper 2 there. That's our paper 2. It's number 3C. There is the question, solve the inequality. Solve the inequality. Solve the inequality. Then I'm moving on to this other simple question. It's a 2001, November 2001. This question is just simple. Number 8A. Number 8A. Solve the inequality. Solve the inequality. So we can use that question for the sake of what? For the sake of practice again. Here I've got the other one. It's a November 2012. It's a replacement paper. It's a replacement paper. Here comes our question, which has 5 marks there. It has 5 marks. There is the question, solve the inequality. Solve the inequality. Then you are required to illustrate your solution on a number line. Illustrate your solution on a number line. There is the question. It has 5 marks again. Then I'll move on to November 2011. November 2011, that's a paper 2 there. We are going to solve number 2A. That's number 2A. Solve the inequality. We have to solve that inequality. We apply those concepts that I taught you. We apply those concepts that I taught you. Then move on to November 2018. That's our paper 2. The question is number 3. It's number 3A. There is the question, solve the inequality. Solve the inequality. In this case, you are given the format in which you are supposed to write your answer, of which I said it's not necessary for you to master that. Just use that concept which says on a number line, any number to the left is less than any number to the right. Then in this case, you are required to illustrate your solution on a number line, but the number line is not drawn there for you. You're going to draw your number line down there. So that's our November 2018. Then the last one, it's our November 2018. That's paper 1. It's November 2018, paper 1. Here comes the question. It's number 14 there. That's our number 14 there. Solve the inequality. There is the inequality that you're supposed to solve. That's 2 marks for that. 2 marks for that. Then write down the smallest integer that satisfies the inequality. So I think we did such questions below previously. We did such questions below. So what you have to do, guys, you have to try and do what and follow those steps that I've been showing you. Otherwise, inequalities are the basics of what of other topics that you're going to encounter as we proceed, especially sets and graphs. We are going to apply the concepts of inequalities in sets and graphs, just because the range of values in graphs are written in the form of what? In the form of inequalities. Also, the integers in sets are represented in the form of what? In the form of inequalities. Otherwise, this is the end of our topic. Thank you for your time, guys. Let's meet on our next lesson where we'll be doing laws of indices.